Hello, ladies and gentlemen. Welcome to our statistics unit. After much hemming and hawing, I decided the best way to handle my 2 weeks being gone for the baby is to teach chapter 12. So, depending on when baby has shown up, this might be a little bit of an odd transition here, but what the goal is we're going to do all of the instruction and practice and activities for chapter 12, and then when I get back, we will kind of wrap and tie everything up in chapter 12 and then continue from wherever we left off when I did have to leave. So, could be in the middle of chapter 8, could be at the very beginning of chapter 8. It all just depends on when the baby decides to show up. But welcome, and looking forward to finishing this chapter. It's a fun one as far as math goes. We've got a little project to go along with it, so hopefully you guys will be able to enjoy it. Plus, this is another opportunity for us to do some math that you'll see in real life. You'll see it on the news, you'll see it in, some of your stuff that you see in a lot of your other classes when you go off to college. So very applicable mathematics that we'll be doing today that a lot of people end up using in some way, shape, or form in their life. So we're going to start off here with section 12.1, samples and studies. So if you can follow along with your note sheet, and we're just really going to be filling that in. So first thing we're going to start off with is a couple of definitions, and the first word we want to define is a population. And a population is all of the members of a group of interest. So when we're doing a study, we're trying to collect statistics on a group of people, we can't usually interview everybody, so we have to look at it in terms of everybody in a smaller group. So that population is going to be the everybody. So some examples might be every student at Mount Pleasant High School. It might be every student in Mount Pleasant. We could even think of every United States citizen. The idea is you have the entire group of people, all the students, all of the Mount Pleasant residents, all of the citizens of the United States of America, every human on the planet. Those are all populations. The second part of that then is a sample. And a sample is when you take a smaller chunk of the population so that you can actually do a study on them. So let's look at that Mount Pleasant High School situation. We have at our high school about 1,100 students, depending on the year. Sometimes it's closer to 1,000, sometimes it's a little more. And if we want to figure out, let's say how many students at Mount Pleasant High School eat hot lunch, we couldn't necessarily ask every student how many we couldn't ask every student if they eat hot lunch or not. We'd have to kind of narrow that down, and we would take a sample of that population of every student at Mount Pleasant High School. We find just a few of them, and we ask, and we let them kind of represent how the whole population feels. What that does then is it gives us a really nice approximation for how that Mount Pleasant student body feels as a whole. We can't ask every kid, but statistics will show you that if you ask enough kids, you can get a really clear picture of how every kid probably feels. So that's kind of how statistics works. We have a small sample that we pull from the whole population to get an idea about how the whole population feels. Okay, we'll look at some types of samples and give you kind of a better idea what that looks like. Take a moment to finish writing this down if you need it, and if you need to pause, do that. We're going to look at 5 types of samples, and the first one is called the simple random sample. So what this is you pick some random dudes or dudettes from a population, and you just pick them randomly. The key thing here is that every subject in the population has an equal chance of being selected in the sample size. So an example of this would just be polling on the street or in the halls. Okay, we'll stick to our high school example. We have our population of every student at Mount Pleasant High School, and you just stand in the hallway, and as kids walk by, you just pull them over and you ask them your question. Do you eat hot lunch? 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 That's a random sample. You just pick people as they're walking by. You don't care if it's a guy, if it's a girl, if it's a junior, if it's a freshman, if it's a graduate. If it's people walking by you, you pull them, you ask them your question, and you move on. That's a simple random sample. The next type is a systematic sample. And what this does is it basically, you pick people, but you pick them based on a pattern or at a specific interval. So instead of just picking random people as they walk by you in the hallway, this might be where you pick every third person who walks through the door. So maybe you stand back at the student entrance near the math pod, and every third kid who walks through there, you say, hey, do you eat hot lunch or not? And they say yes or no, and they move on. And then two kids go through, and the third one comes through, and you say, hey, do you eat hot lunch or not? They answer, and you move on through. Two more kids, hey, you eat hot lunch? And so on and so forth. The idea with a systematic is you have a system in place, a pattern that you're following that determines who you're going to pick. Okay, so it's similar to the random sample, but it's a little more structured in that you're going to pick, like I said, every third or every eighth or every second or every 11th kid that comes by. That's the idea there. Next is one you'll probably be a part of at some point, which is the self-selected sample. And what this is this would be like if you get on Facebook and you say, hey guys, I need everybody to answer this survey. And so you ask everybody to participate, and let's say you have 500 friends on Facebook or whatever social media you like the most, and of your 500 Facebook friends who see this, only 230 decide they're going to click yes and participate in your survey. That's self-selected. The people who participate, they decide themselves if they are going to participate or not. Okay, so that's self-selected. The participants determine if they are going to be participants. Okay, so those are our first three types. Pause the video if you need to. This might be a good time if you guys are, well, actually, no, don't do that yet. Pause, make sure you have this down, otherwise we'll move on. Our next type is a convenient sample, and just like the name suggests, here you're picking people that are easy to reach. So again, to use our example with the school, a convenient sample would be if a senior, say, were to come into class and just pass out surveys during work time. You know, he doesn't necessarily go to every class or try and make sure that he's got a certain type of people. He just pokes his head into a classroom and says, hey guys, do you eat hot lunch? And the people who are in that class say, I eat hot lunch, or I don't eat hot lunch, and he uses that as a sample. The convenient samples sometimes have some problems. We're going to talk about bias here in a little bit, so we have to be careful with the convenient sample. But the idea there is that it's just an easy group. So for your case, a convenient sample would be, well, I'll just ask my friends, and I'll see if they eat hot lunch, and I'll use that as my basis for, does the whole school eat hot lunch or not. That's the idea with a convenient sample. Who's around me, who's nearby, who's easy to get a hold of. The last one is the stratified sample. And I like this one most just because of the name, not because of any mathematical reason. I just like the name stratified. This is when you pick random people from specific groups. So, for example, this one I think is easy to look at as an example. If we want to get an idea of how the entire school feels, we might pick 10 freshmen to ask our question, 10 sophomores to ask our questions, 10 juniors, and 10 seniors to participate in our study. Okay, so this way you split everybody up into groups, and then you pick a certain number of participants from each one of those groups. That's a stratified sample. Just to play around with the world, if you think about the word stratosphere, that's one of the highest layers of our atmosphere. So we have stratosphere and atmosphere, and I'm not a science guy, so now I'm forgetting what the other names are, but the idea is that it's layered. Okay, there's different levels, there's different groups that you pull from. Those create kind of our stratifications, how you're going to split it up, and then you pull an equal number from each of those groups. That's stratified. Okay, or stratified. Pause the video take a moment, work with who you guys are sitting with, talk together as a class, and see if you guys can come up with any of your own examples to add to this note sheet, okay? Examples of each of the types: a simple random, a systematic, self-selected, convenience, or stratified sample. Pause the video and talk about that for a moment. Next is bias. Okay, here's our definition for bias. It's an error that results from not giving an honest representation of the population. So to put that in other words, this is when you collect your data from your study, no matter what type of sample it is you pull, and the data that you get back is essentially false. And it's false because basically of the people that you chose or the way that you asked your question. There's lots of different ways to create bias, and we'll look at a few examples. So here is a couple examples of a biased study. If you're at McDonald's and you ask every eighth person who comes into McDonald's if they eat fast food. Okay, now, first off, let's look at that. Every eighth person. Okay, if you look back to the type of sample that is, that's our systematic sample. Every eighth person, that's who we choose to ask our question. But we have to think about who is coming to eat at McDonald's. It's people who eat at fast food. Very, very few people are going to be coming to a McDonald's and not eating. So if your survey question or your study question is to determine how many people eat at McDonald's, how many people eat fast food, you wouldn't want to go to a McDonald's. You want to go to some place that doesn't have anything to do with fast food and say, hey, do you eat fast food? So maybe you go to a Walmart, or you go to a sports arena, and you say, excuse me, ma'am, do you eat fast food? Excuse me, sir, do you eat fast food? That's going to be way less biased than if you go to McDonald's and say, hey, do you eat fast food? Of course I do. Why else would I be here? That would be a biased study. Another one, asking randomly selected people at the Republican National Convention if they like President Obama. Okay, the Republican National Convention is going to be full of a lot of Republicans, and in general, most Republicans aren't big fans of Obama because he's a Democrat. So if you want an unbiased sample, you wouldn't pull that only from the Republican National Convention. You would have to, again, go somewhere where people aren't being grouped by their political affiliation. You'd have to go somewhere that's a little more open. Same thing, you wouldn't go to a Democratic National Convention and ask, hey, do you support Donald Trump or do you support Marco Rubio? You know, most people at a Democratic convention, they're going to support a Democratic candidate. Most people at a Republican convention are going to support a Republican candidate. So if you're trying to create an unbiased study, you have to be careful about who it is you're asking. That's the idea here. Let's look at some unbiased samples, or excuse me, unbiased studies. Asking every eighth person at McDonald's what their favorite TV show is. Okay, a lot less bias there, because everybody at McDonald's may or may not watch TV, but they're not there because of their TV watching. So it's not like you're going to kind of accidentally lump them together and then ask them about fast food. You're lumping them together based on their food and then asking about TV. They're unrelated, so you remove a lot of the bias. Similarly, asking randomly selected students the state where they went to college. If you were able to ask across the whole nation, you're going to be able to get pretty good data as far as where people are going to college the most versus the other example. So that's bias. Again, pause, talk together as a class about some times when bias might be created and how to maybe make it an unbiased situation. Okay, before we go on, I'm going to go ahead and pause this video and start up another one. I've got some software limitations in place, so I have to stop the video before we get to the end, but move on to part B, and we'll finish up this slideshow there. Thank you.